In section 9.4, we're going to graph what's called a linear inequality, and I hope you've had a chance to listen to the examples that I gave you, because I have a very specific method in mind. It's kind of strange. Even though you need to be able to do these by hand without a computer, it turns out that a pretty good way to do this is to use a computer to practice for a while, and then you'll know what to do by hand. So the first thing to do is to take your inequality and temporarily change it to an equal sign and graph that line. It will be the boundary line. So for example, if you look over here, I've graphed the line. I've graphed the line y equals x plus 2. I'm going to go ahead and center it so it looks a little bit more normal. So there's the line y equals x plus 2. The second thing you do is you pick a test point that's not on the boundary line, and it's easy to use. We could pick this point right here, which is negative 3, 1. We could pick this point over here, which is 2, 2. But if 0, 0 is not on the line, I like to pick 0, 0. And you take the test point and you put it into the original inequality, 0 for y, 0 for x, plus 2. So 0 is less than or equal to 2. Is that a true statement? Yes, that's a true statement. That means 0, 0 is going to be in the shaded part of this thing. Let's go back and look. If 0, 0 is in the shaded part, that means everything below this boundary line should be shaded. Now we can check that by just simply clicking here, and sure enough, the green picture is a picture of everything that's less than this boundary line or equal or on the boundary line, but it's not the stuff above the boundary line. So this is the solution. That's what you need to be able to graph by hand without the help of a computer. So remember these steps. Make an equal sign, graph the boundary line. In this case it's solid because the points on it work. And so just as a reminder, that is the solution. We're going to graph this. We're going to graph the boundary line y equals 6. I hope you know what that looks like. It looks like this. It's a horizontal line at y equals 6. And then we're going to pick a test point. Is 0, 0 on the boundary line? No. So I'm going to pick the point 0, 0. X is 0, y is 0. I don't have an x up here on this original, so I'm going to put in the y equals 0. Is 0 less than or equal to 6? Is that true? Yes, it's true. So 0, 0 is part of the shaded part. What does that mean? That means 0, 0 is on the shaded side of this boundary line, so we need to shade underneath. Now we can click here and see the actual answer. This is the answer that you should be able to produce on your paper without the help of a computer. But the trick is the computer helps you learn how to do this pretty well on your own. So go ahead and use the computer, but be sure you know that the goal is to understand this plan on the left-hand side well enough that you can do it without using decimals on, for instance, an exam. In problem 35, we're supposed to graph this system of inequalities. The system has these two inequalities in it. And the way we're going to do this is we're going to graph this one first, and it will look, something like this. And then we'll have another one, and it'll look something like this, and we'll find the overlap. That's the idea, a reminder of the idea. So let's see how this works. We're going to graph this one first, and so we find the boundary line y equals x, and the boundary line y equals x is right there. Now we need a test point, but my favorite test point 0, 0 is on the boundary line. So how will using 0, 0 help us know which way this thing's shaded? Now since y is on the left-hand side, we have y is bigger than x. We could assume that y is going to go up above this line and be shaded above. But it's so easy to pick a test point. Let's pick this point 0, 2. We're putting in 0 for x and 2 for y. It's the point right here. So when we do that, we get 2 is greater than 0, and that's true. So our test point worked, and we're going to shade up. Now let's take a look at that. I'm going to get rid of the boundary line because remember, the boundary line is now dashed because it's not greater than or equal to, it's just greater than. And now we do the same thing. On the same graph, we do this. So we're going to graph this boundary line, and then we're going to test it. So there's the boundary line. Uh-oh, look at that boundary line. I don't think that's correct. I think I've put in the wrong thing. So let me fix it by getting a minus sign in front of the x. I did some copying that was incorrect. So now let's take a look at the second boundary line. That looks a little better. Oh, that's not the boundary line. There. That's the second boundary line. Which side's going to be shaded? Well, we could pick a test point. On this purple boundary line, 0, 0 is not one of them. So we can use 0 here and 0 here. And 0 is less than 3. That's true. So that means 0, 0 will be on the shaded side of the purple boundary line. That means we're going to shade up and to the right of the purple boundary line. And you can see that when we do this. Now it's not up and to the right. What's happening here? So it turns out that I was really wrong. And rather than re-record, I'm just going to fix the mistakes. I've got no pride here. So this was what I was supposed to have been doing. This was supposed to be the boundary line, and I did not have it correct. I just didn't. I had the wrong equation in there. I didn't have minus x plus 3. I had minus x minus 3. So now we test out 0, 0, and 0, 0 works, but that means it's to the lower left of the purple blue line. And so that means we're going to shade downwards and to the left. And when I click on it, sure enough, downwards and to the left. So where is the solution to this system of equations? The solution is this dark part on the left-hand side. It's a triangle. It starts up here, it goes downwards, and down here. That piece is the solution. Those are all the points that are in this first inequality and make it true, and also make this true. So this point, for instance, 0, 2. If you put in 0 for x and 2 for y, this green inequality is true. If you put in 0 for x and 2 for y, the black inequality is true. So every single point in here makes both inequalities true. These points up here in the light green, they only make the first inequality true. These points down below in the dark gray, they only make the second inequality true. And these white points over here, they don't make either inequality true. But the answer to the solution to the system is these points on the left-hand side, that left-hand kind of triangle-looking thing. That's the solution, where they overlap. So we're going to graph this system of inequalities. And so we find the boundary line by putting in x equals -4. And over here, we can graph that. X equals -4 is this line. I've gone by 5s so that this will fit on here a little bit better. We need to know which side to shade. Now the x's that are bigger than -4 are going to be on the right, so we can shade the right, but we can pick a test point 0, 0. If you put in a 0 here for x, 0 is greater than -4, so that's true. So it's going to shade to the right. Let's see the picture of that. There it is. There's the boundary line at x equals -4. Everything to the right shaded, but the boundary line itself is dashed because there's no or equal to. We want all the points whose x numbers is bigger or to the right of -4. Now on that same graph, we have to graph this guy. So we're going to again look at the boundary line. And you need to be able to graph the line y equals -2x plus 3. That's something that you need to be able to do. But Desmos can help you do it. Notice it has a y-intercept at 0, 3, and it has a slope of -2. It goes down 2 and right 1, down 2 and right 1, down 2 and right 1. So there are clues. 0, 0 is not on the blue line, so we could put in 0 here and 0 here, and we get 0 is less than 3. 0 is less than 3 if we put 0 here and 0 here, and that's true. So 0, 0 is part of the shaded part, so this thing is probably going to shade down and to the left of this blue boundary line. So let's take a look at it. Yes, it does. Now where do they overlap? Well, again, they overlap in this dark green sliver down at the bottom. That's actually the answer. Its right-hand slanted edge is dotted or dashed. Its left-hand vertical edge is dotted or dashed, and everything in there is shaded. Those are the answers. So 0, 0 makes this true and makes this true. In fact, every single pair of numbers in here makes both true. And in this white section, every single pair of numbers, every single coordinate xy point in there makes both of these false. So once again, the solution is the shaded part down here.